Alright guys, welcome to the channel. We're going to be solving question 38 from the first chapter of the Johnston textbook, Mechanics and Materials, and we have this link BC that is 6 mm thick and has a width of 25 mm and is made of steel with a 480 megapascal ultimate strength and tension. So we have the ultimate strength 480 megapascal. That's our first given. Also, since we have the dimensions about link BC, if we try to section it in here, we're gonna see a rectangle where one side is 6 mm and the other side is 25 mm, so we can find the area pretty easy. So that's the section that we do in there. So we can find the area in here, 6 times 25, and since each of them are in millimeter, we have 10 to the minus 3 times 10 to the minus 3 in order to get it in meter squared. So we have, so far we have the area, we have the ultimate strength, and the question is asking for safety factor in order to support a 60 kilonewton load P. So we know the force P is also 60 kilonewton, and we have to find the factor of safety in this question. So we're going to start with drawing the free body diagram of the member ACD. So I'm going to draw the free body diagram of ACD in here. And the forces that we have at point D, we have the force P, and we have a pin at point A, which means we have both X and Y components and no moment since it can rotate freely in that joint. So these are all the reactions that we have, and also we have the force in member BC, we can call it FBC in here, which will be along the BC member since it's a two-force member, and we know this force is perpendicular to this. So we are in equilibrium. We can use our equilibrium equations. By the way, we have a separate channel for engineering mechanics where we cover all these concepts, like free body diagram, the equilibrium equations. I'm going to put the link in the description below if you guys are interested. We get very deep into these details on each support. Since we are in equilibrium, we're going to start with our moment equation about A, counterclockwise positive as always, and that way we can get rid of all the unknowns at point A. So we have basically the moment of FBC, which if we look at it, it will be in this direction. So it's a counterclockwise moment, so positive FBC, and the distance would be what we have from A to C. That would be our distance vector, which is 480 millimeter, so times 480, and also we have the moment of force P, which if we look at it, we'll see about point A is going to make a clockwise moment. So this moment is negative P times the vertical distance to the line of action. This will be the line of action, and the distance that we are looking for is actually, this distance is also a given in the question, but it's missing in this figure. So we know the distance from A to B is 600 millimeter. So this is a given in the question, keep in mind. So if that's the case, we know this distance now is 600 millimeter. P times 600, that will be equal to 0 again because we are in equilibrium. So the sum of all forces and moment has to be 0 in equilibrium condition. So if you want to find FBC in here, we basically have P times 600. We know our P is 16,000. So 16 times 10 to the 3 Newton times 600 divided by 480. I didn't do any unit conversion for these because they're going to be canceled out with each other. So our FBC in here would be 16,000 times 600 divided by 480 divided by 480. That's going to be 20,000 Newton or 20 kilonewton. All right, so we also know that we have the ultimate strength of 480. We know the ultimate strength would be the force over the area, and we know this will be equal to 480 megapascal. So we can find FBC in here. Our FBC, if we find it from the ultimate strength, would be 480 times 10 to the 6 Pascal times the area, which is what we found in here. So 6 times 25 times 10 to the minus 6. This will be canceled out with each other, and we can find FBC in here. So 480 times 6 times 25. Our FBC in here would be 72,000 Newton. So if we want to find our factor of safety, we have the ultimate force in the FBC, which is what we found in here. We can show it with U actually to differentiate it with what we had before. So we can use FBC ultimate over what we found based on the P that we have. So we have 72,000 over 20,000, and that's going to give us 72 divided by 20, which will be 3.6. And this would be the final answer for this question. Again, we looked at the force that we're going to have based on the ultimate strength, and we're going to divide it by what we found based on the T, based on the P that we are given. And if we divide these two, we're going to get our safety factor. Hope everything was clear. Let me know if you guys have any questions. And one thing that was missing again in the question is that distance 600 millimeter, the distance from A to B. But yeah, that's pretty much it. You guys take care. I'll see you in the next one.